2 years ago, when I was still in middle school, I built this model. I never expected it go viral. With the follow-up improved and remade videos, the total views across the internet reached tens of millions. But at that time, my technical skills were limited. The model didn't fully match the game's look or functionality. So, 2 years later, I'm back, completely revamping it, and still fully open sourced. Looking at the in-game model is pretty simple, just an LCD screen and a main board. One thing to note, the game's LCD uses a 10-pin ribbon cable, but in real life, the LCD 1601 has 16 pins. That seems like a problem. How do you run a 10-pin ribbon on a 16-pin screen? After a bit of research, I found that LCD 1601 can run in 4-wire mode. This saves 4 pins compared to the original 8-wire setup. Then, by connecting the backlight and the main power together, and tying the RW pin low, write-only mode, it all adds up 10 wires total. Perfect. Another thing is the numeric keypad on the board. Compared to regular Matrix keypads, the in-game font is unique, with subtle differences. Luckily, after some digging, I actually found one with the exact same style in Taobao. Once the prep work was done, I sketched the circuit and PCB. For the main chip, I stuck with the popular STM32F103C8T6. And I also integrated the voltage regulation circuit onto the board. That way, no external module is needed. The terminals were upgraded to KF103 for a more authentic and 3D look. I also swapped the LEDs for red-green bicolor ones. With PWM control, we can now produce red, yellow, and green lights, 3 colors in one. After the circuit design came the prototyping and soldering.
妈妈坐在门前，捧着花儿的少年。虽时隔多年，记得他泪水涟涟。那些幽暗的时光，那些坚持的慌张，在临别的门前。 妈妈望着我说：“生活不止眼前的苟且，还有诗和远方的田野。你赤手空拳来到人世间，为找到那片爱不顾一切。”
This project uses a lot of SMD components. If you want to recreate this, but do not have a hot air gun or reflow station at home, you can use JLC SMT, the sponsor of this video. Basically, SMT service means that the factory does all the soldering for you. JLC goes a step further. They handle PCB, components, and SMT. Everything comes ready to use, no hands-on soldering required. Here I have finished the PCB design. When you order, just select SMT assembly, and you will get a fully functional board straight out of box. Next, a huge shout out for the amazing Netherstone for helping with the 3D printing, making the main switch housing, and after a quick assembly, the hardware part is complete. The software side, no surprises here. I spent about 15 minutes writing a prompt that detailed the microcontroller, development environment, pin configuration, and all the features I needed. Then I let AI generate the code. 30 minutes later, I flashed it, and it worked perfectly on the first try. Besides all the basics, password, countdown, and diffuse features, this model still keeps the output function. The boards relay closest after the countdown, sending power. And we know a heating wire glows red when powered. So all we need is a bit of high school chemistry. Or maybe just demo it with a balloon. Now connect 2 output wires to the heating wire and attach it to the balloon. Let's test. Currently, More open source materials are uploaded to GitHub and JLC hardware open source community. Links are in the descriptions below. If you enjoyed this video, don't forget to like, subscribe, and hit the bell for more builds like this. Thank you.